guys, in today's video we're going to look at periodic trends in ionization energy, and we'll look at an exam style question.
So first of all, let's just remind ourselves of what exactly ionization energy is. Well, first of all, we're going to look at the first ionization energy. Now, this is the energy needed to form positive ions, and we're always working with atoms in gaseous states. So this is the equation that can be used to define the first ionization energy, and that's the removal of 1 mole of electrons from 1 mole of gaseous atoms to form 1 mole of 1+ ions. And you can see that here we have 1 mole of gaseous atoms and we're forming 1 mole of gaseous 1+ ions, and we're removing 1 mole of electrons. Now we know there are a number of factors that affect ionization energy. These factors include the atomic radius, the nuclear charge, and the level of electron shielding. And it's these 3 factors that influence the trends that we see in ionization energy. So let's have a look at some of the trends in first ionization energy. The first trend we're going to look at is the pattern that we see across a period. Well, across a period we see an increase in the first ionization energy, as you can see here in this graph of the first ionization energy of period 3 elements. Now, the reason we see that increase is because we are increasing the number of protons and therefore increasing the nuclear charge, reducing our atomic radius. We're pulling those electrons in tighter. Now, we have the same level of shielding, or around the same level of shielding, because across our period, the electrons are being removed from the same level, the same quantum level. So now let's have a look at the trend down a group. So here we have the graph of the first ionization energies of group 2 elements, and here we're moving down the group. Down the group we see a decrease in the first ionization energy, and that's because we have a larger atomic radius down the group, and also more screening or more shielding by the more shells of electrons, that we have as we move down the group. The third trend we're going to look at is when we see some decreases. We'll see a decrease between group 2 here and group 3 here, and one between groups 5 and 6. So I'm going to explain why we see those decreases in ionization energy now. First, let's have a look at the decrease between groups 2 and group 3. Well, we have beryllium, which is in group 2. That has an ionization energy of 900 kilojoules per mole, whereas boron in group 3 has a lower ionization energy of 799 kilojoules per mole.
Hey guys, to continue watching this video and unlock hundreds of other super concise and exam board specific A-level chemistry videos, click the button. Join me today, and together let's make A-level chemistry a walk in the park.